Next example, we have we are given the initial voltage as 0 volts, and IL of 0 plus equal to negative 12.25 milliamperes. So calculate the roots of the characteristic equation. Calculate V and dV dt at t equals to 0 plus. Then find the expression for V of t. We are given V of 0 plus equal to 0, and IL of 0 plus is equal to negative 12.25 milliamperes. So first is calculate the roots of the characteristic equation. So first we need to find alpha and omega naught. So alpha is just equivalent to 1 over 2 RC. We have a value of 200 rad per second. For omega naught is 1 over square root of LC. We have 10k rad per second. We can see that our alpha is less than omega naught. So this means that our circuit is underdamped. Which means that the expression for V of t is equal to e to the negative alpha t times a1 cosine of WD t plus a2 sine of WD t. Finding the roots, we need to calculate first WD equivalent to square root of omega naught squared minus alpha squared equal to 979.8 rad per second. Our roots for the characteristic equation is equal to, we have negative 200 plus minus j 979.8 for A. For B, calculate V and dV dt at t equals to 0 minus. So we are given the V at 0 minus, V at 0 plus. So VO just equivalent to VO at 0 plus equal to 0. Now since the voltage at 0 plus is 0, so meaning our current at the resistor at 0 plus, current at resistor at 0 plus equal to VO of 0 plus, V of 0 plus over R. So if this is 0, our current in the resistor at 0 plus, or T at 0 plus is equal to 0 years. So this means applying KCL at top node, IC plus IL plus IR is equal to 0. This is 0. IC is just equivalent to negative IL. So IC at 0 plus is equal to 12.25 milliamperes. So we all know that the current in a capacitor given by this equation. So dV dt at 0 plus equal to IO of 0 plus over C, IC of 0 plus over C is equivalent to 98 k, k volts per second. For C, find the expression of V of t. Now, same process as the previous example. At t equals to 0 plus, you have 0 equal to e to the 0 is 1. We have a 1. Cosine of 0 is 1 plus a2. Sine of 0 is 0. We have for a1 is equivalent to 0. So how do you find the value of a2? So we need to derive this expression dv dt is equal to, we have the derivative of a product of negative alpha e to the negative alpha t times this expression a1 cosine w dt plus a2 sine w dt. We have plus e to the negative alpha t and the derivative of this expression. So we have negative a1 wd sine of wdt plus a2 wd cosine of wdt. So at t equals to 0 plus, so dv for dt at 0 plus, we are left with cosine of 0 is 1, sine of 0 is 0, e to the negative, e to the 0 is 1, we have negative alpha a1 plus a2 wd. Now if our a1 is equal to 0, so our a2 is equivalent to dv over dt at 0 plus over wd is equal to n 9k over wd. This is approximately equal to 100. So we have our v of t is equal to 100 e to the negative 200t sine of 979.8 t. So this is v of t volts. So graphing v of t, this is what it looks like. So I have 0 initial value v of t, and it oscillates from positive to negative.